Let me show you how to write the Verilog code for SR flip-flop using negative edge trigger. So every Verilog code starts with a keyword called as module. So module, next comes module name. So I'm using a name called as SR flip-flop underscore neg edge trigger. So module name. After this, port list. So in SR flip-flop, output is nothing but Q. Inputs are S, R, and clock, and every line should end with semicolon. So next comes port declaration. So port declaration is nothing but what are the inputs and what are the outputs we need to declare here. So first I'll write output. So here output is nothing but Q, and inputs are nothing but S, R, and clock. So here I'm using a style called as behavioral modeling. So in behavioral modeling, there is a keyword called as always. So always at the rate negative edge of the clock. So always at the rate neg edge clock. So whenever there is a negative edge trigger is nothing but coming from 1 to 0. This particular case statement should get executed. So case concatenate. I want to concatenate S and R. So concatenation operator is used to group multiple variables. So whenever two unknowns are there, there will be four combinations which are nothing but 0, 0, 0, 1, 1, 0, and 1, 1. So they should be declared like this. To take binary 0, 0. So whenever S and R are 0, 0, what is the output? Means simply here we need to follow the truth table of SR flip-flop. So here output Q, which is less than or equal to Q only. Here this less than or equal to is nothing but non-blocking procedural statement, or you can call it as non-blocking assignment. So for 2-tick binary 0, 0, output Q is nothing but Q, which is nothing but memory. Next 2-tick binary 0, 1. So for 0, 1, output is nothing but 0. So Q less than or equal to 1-tick binary 0. Next for 2-tick binary 1, 0. Q is nothing but 1. So 1-tick B1. So the last combination is 2-tick binary 1, 1. So here output is nothing but complement of Q. It is complement of Q in terms of JK flip-flop. But as here we are going with SR flip-flop, the output will be don't care. So instead of don't care, I will give it as high impedance, which is 1-tick BZ. Here Z stands for high impedance state, which is nothing but floating. So whenever there is a case statement, it should end with end case. And whenever there is a module, there should be end module. And one more important point that you need to remember while writing behavioral modeling, always output is treated as register. So add a keyword called as register. And initially I need to give some amount of value for this, which is either 0 or 1. So why I'm giving the value of Q as 0 initially? If you observe in the truth table, when S and R are 0, 0, output is nothing but Q, which is nothing but memory. So if you won't give any initial value, you will get answer as a don't care. So in order to overcome that problem, we need to give some initial value for Q. So this is how we can write the Verilog code for SR flip-flop negative edge trigger.